Let's take an example which includes some numerical values, like a rocket is ascending at 12 meter per second. It turns off its booster at 22 meter above the ground. Students, rocket ascending with 12 meter per second, right? That means it's moving with constant velocity, right? Until you are going to turn off its booster acceleration, right? Now when its booster is turned off at height 22 meter, its velocity was 12 meter per second. Now g will be acceleration, and that will be the negative acceleration. This g is going to retard it. At some height it will reach to the some height, and then its velocity will become 0, and then it will come back, right? Now in A it has asked how long will it take the rocket to reach its maximum height. How long it will take to reach the maximum height. So if we say this is the ground, and this was the position at 22 meter, and we have to look from A to this maximum position, we can say B. We have to find out this time. So for this time, for A to B, can we write, we have VI, VF and A, delta X and T. So it has asked about the time, how long. That means it's talking about the time, how much time it will take to reach the maximum height. At maximum height, velocity will be 0, initial velocity was 12 meter per second at position A, and acceleration we have minus 10 meter per second square, right? Instead of 9.8, just for sake of calculation take 10 meter per second square. But you have to remember, if in your question it has asked to use 9.8, you have to use 9.8. If there is given you can use 10, then use 10. So students, which equation will be suitable? We can write VF equals VI plus AT. So time we will have VF minus VI over A. That means VF we have 0 minus 12 over minus 10, so we got 1.2 second time it will take to reach the maximum height from 22 meter, right? From the height of 22 meter. Second question is, how high will the rocket rise? It is already at 22 meter, then after 22 meter, how much height it will go? So students, can we apply directly that formula for AB? For HAB, can we write height of AB V square over 2G? What is the V? 12 meter per second, right? 12 square over 2 into 10. So we can write 76 over 10, 7.6 meters. How high will the rocket rise? So 22 plus 7.6 meter. So HB from ground, that will be 22 plus 7.6, right? That will be 29.6 meters. See, it has asked how long will it take the rocket to reach the ground. So students, C, for the C, look what is happening from the 22 meter. Initial position is at 22 meter, it's going up, then coming back here. So here you cannot apply the formula of time period, because it's not from the initial position to again initial position. Final position, initial position is not same. So you cannot apply that time period formula. You have to write the equations Vi, Vf, quantities you have to write Vi, Vf, A, delta Y and T, right? We have asked about T and we know delta Y will be minus 22, acceleration will be G, that is we can take minus 10 meter per second square, minus 22 meter, Vf we are not interested, and Vi is 12 meter per second square. Students, we are taking upward direction as positive direction. Which equation will be suitable to apply? Which equation will be suitable to apply? Delta Y equals VIT plus half AT square. Let's apply this equation. Minus 22 equals Vi is 12 into T and minus 10 over 2 into T square. So we got 5T square minus 12T minus 22 equals 0. We can write the T as minus B plus minus under root B square, that means 144 plus 2AC, B square minus 4AC. So 22 divided by 2A, that is 10. So this will be bigger than 12. So time cannot be negative. So our answer from here will be T equals 12 plus, not minus portion, right? B square minus 4AC, 420 and C is 22. Okay, so we got 440 plus 144, 588, root of 588 and over 10. We can solve this, we can simplify this, we'll get the answer. We can see 4 will be the common, so we can take the 2 outside, so it will be 6 plus sum in root over 5. So dividing with 4 will give us 1, 4, 4 7 ja. So this is our answer. We can put in calculator and we will get the exact value. So this second will be our answer. So we got the A, B and C. Now D. With what speed will the rocket strike the ground? With what speed it will strike the ground? So we can use this situation. With what speed? So we need to find out final velocity. So students, can we apply Vf equals Vi plus, time is complicated. So I am going to avoid the time using time, right? So if I am going to avoid the using time, so I have to apply Vf square equals Vi square plus 2A delta Y. So students, Vf will be Vi square, that means 12 square root of this, and obviously it will be plus minus, so we are going to write plus minus 12 square plus 2 into minus 10 into, what is this, minus 22, right? So we know velocity will be in downward direction, so it will be negative because we are taking upward direction as positive. So here this will be 144 plus 220 into 22 is 44 into 0, right? So it will be minus of add these two and calculate the answer. So 588. meter per second, root of this will be meter per second in downward direction, speed will be, right? Students, here we have 2a delta y. In the last one, if you write the formula for this, it's 4ac. Yeah, it's good. Here we had 2a. Okay, that was different. 4ac, 4a is 5. Okay, it was something else. Okay, so I hope you understand this question and concept behind it. And it was a different situation. Here, rocket is at height of 22 meter, right? And then its booster is turned off, right? So it was totally different question than using directly formula for time period or maximum height. I hope you understand this question and concept behind it. Let's go for the next question. Choosing a coordinate system, a baseball is thrown upward with initial speed of 35 meter per second. What is its velocity at t equals 2 seconds? If up is the positive direction, okay, so first we are going to take A as upward as positive direction. Students, baseball is thrown upward with initial speed of 35 meter per second. Velocity at t equals 2 seconds. So write the quantities Vi, Vf, A, delta y and t, right? We have asked about the velocity at t equals 2 seconds, and we know initial velocity is in upward direction, so 30 meter per second plus 30 meter per second, and obviously gravity is going to retard it, minus g minus 10 meter per second square. We are writing minus because we are taking upward direction as positive. Which equation will be suitable? Vf equals Vi plus At. So Vf we will have 35 minus 10 into t is the 2. So 20, 35 minus 20, that means it will be 15 meter per second. Plus 15 meter per second, that means at 2 seconds it's moving in upward direction with speed 15 meter per second. Second is, we have to take downward direction as positive. So students, if you are going to take downward direction as positive and it was thrown with 35 meter per second upward, so let's write Vi, Vf, A, delta y and t. Time is 2 seconds, acceleration again downward direction positive. So this time it will be plus 10 meter per second square. And if you have thrown upward with 35 meter per second, so initial velocity will be minus 35 meter per second. And we have to find out the final velocity. So students, which equation will be suitable? No displacement equation. So write the no displacement equation. Vf equals Vi plus A delta t. Vi is minus 35 and this is plus 10 into t is 2 seconds. So we got minus 15 meter per second. Velocity is negative at t equals 2 seconds. That means it's moving up. Why? Because we have taken downward direction as positive. I hope you understand this situation, this question and concepts, right? Let's bind up final free fall here. In the next lesson we will learn displacement, velocity and acceleration graphs.